Hello guys, we are doing adding and subtracting radicals today. So I have you guys starting with just a review over exponents because they're very similar. So like this first bullet point talks about when we multiply. So when we multiply, we know from back in unit 6 that 2 times 4 you just get 8, and then we add our exponents. So it would be 8x to the 6. That was from unit 6, like the very first unit of the semester. So this is a review over when we are multiplying, we can multiply unlike terms, okay, where there are different exponents, because all we do is we add those exponents, right? Okay, so they will be changing when you multiply. So for example, in that first one, 2x to the third times 4x to the third is 8x to the sixth. Our exponent changed. However, we also learned in that unit that when we add these, adding or subtracting, we cannot add or subtract unlike terms. So if these were not the same exponent, we could not add them together. Okay? But when we do, if they are like exponents, then we can just say that this would be 6x to the third. Okay? And our exponent is not changing. We did this a lot last unit. So when we just add, it's just adding the or subtracting the coefficients or the numbers in front. Okay? So 2x to the third plus 4x to the third is just 6x to the third. So keep that all in mind because it's very similar today. Now we're just in radicals. Okay, so we're saying, how does this apply? Okay, we've done this up until, this is what the quiz was over. So 3 radical 6 times 2 radical 5. We know that we can, it's like outsides with outsides, insides with insides. So this one, which we already know from that quiz, would be 6 radical 30. Okay, because we multiply the outsides and we multiply the insides. So when multiplying, we can multiply unlike terms. So radical 6 and radical 5 are different, but we can multiply them. We just multiply them together and put them under one radical. Okay, so it is okay if we have different radicals when we multiply. Okay, and the number under the radical after will change in your answer. Okay. Now we're going to talk about these two. So adding and subtracting and the differences between. Just like with exponents, we cannot add or subtract unlike terms. So in other words, we cannot add or subtract when these radicals are different. So 3 radical 6 plus 2 radical 5 is not allowed. Okay? So our answer is literally 3 radical 6 plus 2 radical 5. We're not allowed to add those because these two were different, okay? So here, when we do have like radicals, notice they're both radical 3's, just like exponents. We're going to add the numbers in front, and our radical is not going to change. This is just something you have to commit to memory, okay? So our radical, when we add or subtract, just like our exponents, will not change. Think of it as I had 7 radical 3's, and I'm adding 4 more radical 3's. How many radical 3's do I have? I have 11, okay? So again, we're just going to multiply the numbers in front or the coefficients. Okay, I'm going to take you through a couple more, and then we'll just add one more layer onto this concept. So we'll start go right here. Okay, so we're adding and subtracting. First, you need to just identify what are the like radicals. Radical 7 and radical 7. Notice, this is not a radical 7, so it cannot be added to these two. So I have 4 radical 7 plus 5 radical 7. These two come together to be 9 radical 7, okay, adding the numbers in front. So people are like, okay, but what about this one? If you cannot combine it with these two, you literally leave it as part of your answer. So our answer is 9 radical 7 plus 7 radical 2, because this one was not the same, so it could not be added to 9, okay? So look at this one. Are they like terms? Try it out, pause it. They are. This is just saying 5 radical 6's minus 1 radical 6 is 4 radical 6. Okay? And we're going to keep on moving. And you can always pause me and rewind, of course. Right here. Look at this. Now we're just going to add where it's a little bit more work just because they don't look similar right away. Okay? Right off the gate, 3 radical 5 and radical 80 are unlike radicals. Okay, so from what we just learned, we cannot combine them because it says if they're not the same, we cannot add them together. However, we have done a whole 3 units or 3 sections over this. Radical 80 can be simplified. Simplifying just means factor tree. Okay, if you have a big number under a radical, you have to check to see if you can break it down. So I'm going to break it down. 8 and 10, 4 and 2, this is 2 and 5. This one goes down further to 2 and 2. I'm going through this fast because we've already done it a lot. I have 2 pairs of 2's, left over is a 5. So I'm going to rewrite this entire problem. My radical 80 becomes 4, it's a 4, radical 5. Now look at the problem. They are now like radicals because now I have 3 radical 5, which was from the original, plus now instead of radical 80, I'm just going to write what we just broke it down to be. So what's our final answer? Now they're like terms. So 3 radical 5 plus 4 radical 5 is 7 radical 5. Okay? So we're just going to practice this. So for these 3, again, pause it, try it on your own for a second. They are not like currently, but it doesn't mean they never will be. So this one, you're going to have to break them both down. So come over here, 3 and 9. 9 becomes 3 and 3. Rewrite. Now the new problem would be 3 radical 3. Okay? I'm going to stop. I'm going to pause. I'll put my sign so I don't forget that. Just drop that down. Okay? Radical 12, break that down. See if I can get it to be a radical 3. 2, that's a 2. And 2. Okay? So a pair of 2's would become 2 radical 3. Now look at my problem. Now I have 3 radical 3 instead of that, and 2 radical 3 instead of that. Subtract them, because now they are like terms. So 3 minus 2 would be 1 radical 3, or just radical 3. You don't have to write the 1. Okay? Moving on to this one, you can break them down, or you got to be good at recognizing perfect squares. What's the square root of 25? Just straight 5. What's the square root of 64? Just 8. Remember, if you square root, if you put this in your calculator and get that it's 5, it does not have a radical anymore. Are these like terms now? Yes, they are. Neither of them have a radical, so they are like terms. Last one is radical 18 plus radical 36. Check and see if you can simplify one pretty quickly. 36 is just 6, right? Because it's a perfect square. This one, however, you can break it down. That's a 9. And then 9 breaks down to 3 and 3. So there's my pair. My new problem is 3 radical 2 plus, that's a 6. Okay? So now you have to look at this. Is 3 radical 2 and 6, are those like terms? Some people will say yes, just because 6 doesn't have a radical at all, but that is not similar to 3 radical 2. So this answer is actually just 3 radical 2 plus 6. Okay, you cannot combine those in this case. Alright, and last couple here. Just adding some more stuff into it, okay? So now, same thing, these are not like terms, so just what we did above is we do have to break them down, see if they can become similar. So 9 and 3, 3 and 3, this now becomes 3 radical 3. The difference with these is you can't forget about the numbers they had originally, or out in front. So just drop it down. If you do it in one step, you can, but don't feel like you have to. You can just drop it down for right now. 75 would be 3 and 25, 5 and 5. So my 5s would go out and my 3 would stay in, but just don't forget about the 2. Okay? So now just cleaning it up, 18 radical 3 plus 10 radical 3. Okay? Are those like terms? they are, so just add the numbers in front. Okay, so just not forgetting about the 6 and the 2. Okay, alright, so what we're going to do here, lost my spot, is I'm going to have you do number 5 on your own, okay, and I'm going to put the answer, so do try this one out. You do get 0, okay, so try this one out, make sure you get 0. But I am going to work through this one with you right here, okay, so I already started to break it down, but to break it down a little bit further, I don't know why there's a 2 there, 54 would break down into, I'm going to pick 9 and 6 instead, okay, 9 would break down to 3 and 3, and then 6 would break into 3 and 2. So my pair, I have my 2 on the outside, but then my new radical on the inside would be 3 radical 6. And then I'm going to break down 108, which actually goes into 2 and 54. And then we know how 54 breaks down because we just did it. Look for your pairs, pair of 3s. I also have a pair of 2s. Don't forget about that too. So here's what this one looks like. I actually get 6 radical 3. Already, notice, these are not like radicals. Okay, so let's clean it up a little bit and then see if we can actually go anywhere with this. I'm now at the point where I've cleaned this up. 2 times 3 gets me 6 radical 6, and I drop this down. These are not like radicals, so I cannot do anything further with adding the numbers. So that is my answer. Okay, and then I also want you to just try this one on your own and make sure you get -4 radical 10. Alright, that's it for today. Get on Canvas, do that 8-question Canvas quiz, and I'll see you guys Monday.